Hi, in this session we will discuss producer consumer example. Here this is based upon the inter-thread communication. Already we have discussed the synchronization implementation by using the synchronized method or static synchronized method or synchronized block method. After that we can use inter-thread communication between different threads. In this scenario, we are having two threads, producer thread and consumer thread. That producer thread and consumer threads are sharing a fixed size common buffer. Here we are going to use the queue, right? The name is queue, but we are going to use the Java collection vector data structure in the example. So you assume that this is having four memory locations. Okay, so in that time, four memory locations, here you are going to store the data by using producer's thread. The producer thread generate the data one by one. At the same time, it will be stored here. For example, first data is produced and stored, then second data is produced and stored, then third data is produced and stored, then fourth data is produced and stored continuously. So once the queue becomes full, okay, that buffer becomes full, then producer cannot store the data into the buffer because this already filled all memory locations. At the same time, the consumer is consuming the data, that means removing or deleting the data from the queue one by one based upon the first in first out method. So first he will remove the first data, then queue becomes queue have some memory location, empty memory location, so then he can store another data. And here second data is consumed by the consumer, third data is also removed by the consumer, fourth data also removed by the by the consumer by consuming. So now buffer becomes empty, right? If buffer becomes empty, then again consumer cannot remove any more data, right? So that is also to be alerted to the user. So two things should be observed here. If queue becomes full, then alert message should be given to the user that queue is full, producer cannot add any more data. Likewise, the alert message to be given to the consumer when the queue becomes empty, he cannot delete any more data from the empty buffer. This can be achieved by using inter-thread communication between the synchronized threads, okay, using concurrency control mechanism. The synchronized methods are created for the producer thread and consumer thread. Both are going to working over the same object. That object is here queue, right, by using the vector Java collection data structure. Okay, this is a dynamic data structure. We can increase the data size and decrease the data size if you are not mentioning, but here we are going to mention the data size as a, memory size as a 4 for our example. So now in this example, based upon the previous scenario, producer thread and consumer thread, we are going to use, both are using the same data structure. The data structure is here shared queue. I am giving the name here, shared queue is the buffer name. So based upon this, I am creating the class producer, right? Based upon this, I am implementing the runnable interface. This is providing the multi-threading features to producer class. Then I am creating vector object shared queue as I said here. Then size of the shared queue is given here. Then producer constructor, which is receiving the shared queue value and size value from the main method, right? So from the main method we are going to receive the data. I am showing here the main method is calling the producer constructor by passing shared queue name. Okay, shared queue name is here vector data structure. I am creating the vector data structure by with the name shared queue, right, that having the size, okay, 4 memory locations, okay, 0 1 2 3. So 4 memory locations I am passing over here. Thread name is producer. So based upon that, now here we receive the data. Shared queue is the data structure we have created with 4 memory locations, right? Then the size is given here as a 4, right? Both are assigned to the respective fields of that data structure, right? Shared queue is the name, right? Then the action portion is defined here 7 iteration. That means 7 data going to be produced one by one, and I am calling the method after producing one data, that is the iteration number. Iteration number is assumed as a data here. Okay, the first data is produced, I am passing to the method produce of I. Okay, here the produce is the method which is receiving the data. First iteration, first data is receiving. Then now shared queue size is as of now empty. Okay, so in this empty shared queue we are going to store the one at the first memory location, I mean 0th memory location, right? Then we are checking, right? Here this is using synchronized block. Okay, synchronized block approach to make this part of the code is the synchronized code. Okay, now which is checking if the shared queue is here entire data structure, the name of this buffer. Here just it is checking if both are equal. Number of elements in the shared queue is now 1. Okay, the total size of the memory is here 4, so 1 equal to 4, so which is false. If it is false, then you look at that we are adding the data, we are adding the 1. Okay, we are adding the data, right? Adding the data into the data structure. The data structure name is here shared queue, right? We added the 1 into the data structure. Then we are calling the notify all method. If any waiting thread available, then that thread will be wake up and coming into the execution. Then another method is here consumer class is having that is having consumer constructor, right? So if data is available in the shared queue data structure, name of this buffer is shared queue, right? So already we have inserted one in the producer thread. Now the structure is passing over here, the size is here we are passing, right? And that is respective size is assigned here. Okay, after that the action portion is defining. This is consuming action. Okay, that means removing the data from the buffer. So now item consumed from the memory, look at that we are consuming the data by calling the method consume. So here the consume method is having the data. As of now shared queue is having only one data. Okay, which is having one data, so that is 1, right? So as of now is sad queue empty? No, it is not empty. Then what will be happen here, which is notifying all the remaining threads. That is here remaining thread is only the producer, sending the notify all method to producer, and which is removing the 0th memory location data. Okay, so the data is removed here. Okay, so that data is removed by the consume method. Now here you see based upon these threads one by one we are calling by using the start method, that portion will be done. So now we will see how it is executing in this example. Okay, so first we are calling the producer thread as per our example. The memory name is passing, the size is 4. Okay, so as of now you see the producer is called. Here the run method is invoked by calling the start method here. Okay, so the start method is here. Okay, which is calling producer thread, this one which is having shared queue and with size is 4, name is producer. Okay, so based upon that, here we are calling the producer thread. At the same time, within the microseconds gap, okay, within the microseconds gap, the consumer thread also calling the consumer constructor, the shared queue data structure with size is 4, and which is also invoking the run method, which is available in the consumer thread, right? This portion, right? Consumer thread is also having a run method, right? So consume action or produce action from this respective threads. As per this output here, initially you see consumer got the CPU for execution at that time, which is saying the memory is empty. Initially, you look at that, okay, initially the consumer got the CPU, right? Shared queue and size is 4. Initially, there is no data. As of now, you assume that there is no data because this is the first iteration. Okay, in the first iteration, we are not having any data in the buffer. So, which is showing empty, showing as a empty here. So here what will be happen, the item consumed from the memory, which is uh, right, it's not possible as of now. So consumer is waiting, so which is showing total data in the memory is 0 because initially the consumer thread is executing the thread before the producer thread. Then you look at that in the consumer thread here, which is if it is empty, okay, the memory is empty, then that thread name is displaying total data in the memory is 0. That's what which is showing here, total memory is here, data in the memory is 0. Then which is sending wait signal to this consumer thread. So consumer thread will be waiting until getting the notify method, right, from the producer thread. So now producer thread will get the turn, so then it is started, then item is produced. Once it is started, run method from the producer, okay, is executing here. So run method is executing the first iteration is executing, data 1 is produced, then we are calling the produce method by passing first data. Now the first data is passing here, then we are checking the shared queue size is as of now empty, empty equal to 4, that means 0 equal to 4, it is false. Okay, it is false. So now shared queue is passing to the synchronized block is the method here we are using. So adding into the shared queue, what is the I value? 1 is added into the shared queue now. So 1 is added into the buffer. Then notify all, we are waking up the threads which are waiting. So which is the thread waiting here? You look at that, consumer thread is waiting. Okay, so now it is waking up. Okay, at the same time you look at that, still that thread is waked up. Okay, so now the thread lock is still, which is having to produce, okay, within the microseconds, right? So you look at that, second data also produced by the producer thread, then third data also produced, and fourth data also produced. So after waking up by the consumer, in the meanwhile, right, so there is a waiting delay is introduced for the consumption, so 50 milliseconds. So in that time, in that 50 milliseconds only, this 4 data is produced by the producer memory after the wake up signal notify method. Okay, after wake up signal from the producer, right, after inserting the data 1, the producer is producing 4 data, right, in that 50 milliseconds waiting time. Okay, that is the thing, right? So now the first data is consumed from the memory. As of now, you look at that, still buffer is having 3 data. So first data is consumed, still this second data, third data, fourth data is available in the memory. Okay, then consumer is producing fifth data. So fifth data is written in the first memory location because it is now deleted. Okay, then now item 6 is producing, but you look at that it is already full. Okay, so sixth data cannot be inserted. That's why it is showing memory queue is full. Producer should wait because total data in the memory is 4. You look at that 1, 2, 3, 4. 4 data is there. So now consumer it should wait by passing the signal. You look at that producer right should wait when queue size equal to number of items in the queue. Okay, number of items in the queue equal to 4 and size of the queue is 4, both are equal. At that time it should wait by using the synchronized concept. Memory queue is full, so total data in the memory is here 4. I mean then it is passing wait signal to the producer, so producer should wait here. Okay, until getting the notification signal, right, from the consumer thread. Okay, so until that he has to wait. So now you look at that consumer is consuming the data 2 from the memory. Then now after consuming, you look at here, he is passing, after removing the data he is passing the notify method. So now he received the notify method from the consumer, then he will start the production again. So that's what you look at, that the seventh data is produced, right? So before that the sixth data is inserted after removing the 2 in this location. This 2 is deleted, then 6 is inserted. Now 7 is produced, but you see still the queue is full. Okay, in the 0th memory location 5 is there, second memory location 6, third memory location 3, this one is 4. So now you look at that the item 3 has to be consumed, right? It is consumed, right? So before that queue becomes full, so total data in the memory is 4, right? So producer is waiting. Consumed memory is here 3, then in this step 4 is consumed. Now 5 also consumed here, then 6 also consumed, right? The once this 3 is consumed, 7 will be inserted automatically. Okay, once the memory location is available, empty memory location, then automatically the produced data in the waiting queue will be inserted. Then finally 7 also consumed. Now the memory is empty, right? So total data in the memory is 0. We have used only 7 number of iterations, that's why it is stopped here. Okay, only 7 number of iterations, 7 data will be inserted one by one based upon the queue concept, right? First in first out, like that. So like this, here the producer and consumer threads are communicating with each other by passing the wait signal and notify signal. Okay, notify or notify all signal. Okay, so by using these methods the threads are communicating with each other based upon the synchronization concept. Thanks for watching.